we're looking at the accessory bus options, part 2. If you haven't seen part 1, it's worth getting back and looking at that. It covered commercial systems, but it also covered the general principles of accessory buses. We'll briefly review them before we start. I should say that I've got an iron in the fire, like politicians do or are meant to do, to declare an interest, in the sense that it was me that brought in the easy bus system, which is one of the 3 we're looking at today. As we said last time, that the facts on each one are taken from the documentation of them, but the pros and cons are completely subjective. One man's meat, etc. What somebody finds attractive might be found to be overbearing for somebody else. We can look at that as we go along. We defined accessories in those terms, anything that's non-traction. We also said to take into account the facilities you might want along the way. You'd probably want most of these to be looked at, and you'd also want to take into account how you want to control your layout from the various options that are shown there. So taking it from there, let me just review very quickly. We said that a bus system relies on having a wire that runs around your layout, and you can, along the way, you can attach various modules. Some can be inputs, some can be outputs. You can have switches onto the inputs or buttons or anything that changes the state. And then in changing those, you're going to change the outputs on the output modules. And you can have more than one input module, more than one output module, and therefore they all have to have individual unique addresses. And you communicate between the input and the output by sending messages rather than having hardwired. There's only 2 wires that have to run around your layout. That's what we discussed on part 1. And in part 1, we looked at these. And today we're looking at peer-to-peer light, easy bus, and C-bus. I should say that you take your pick. It depends how complicated your needs are, whether you need simple activities or complex activities. There's no one right answer. So they're not competing, they're complementary. Somebody might think that peer-to-peer light is all they need. Somebody might think that C-bus gives them the flexibility they need, or EasyBus sits somewhere in the middle. So we'll look at all of these and contrast them. Starting with peer-to-peer light, it works on the basis, again, of having a bus wire running around the layout, and of course, 12-volt power, which most layouts have as a bus anyway. It's got an input module, output module, and a control module, which communicates with both of them. And the dotted lines mean you can add on extra inputs, extra outputs. Peer-to-peer light then can be extended that way. You have an input module. At its simplest, can have something that changes the state, brings that pin down to 0. It sends out a signal on the bus, and the appropriate output in the output module will also change state. That pin here will go from high to low, whatever, and in this case brings on an LED. Although it could be any other thing that you want to tie onto this pin. In practice, however, the bus doesn't connect the modules directly. They have what they call backplanes. Think of it as a socket in which you can plug each module. So they just connect to the bus, connect to the power, 5-volt power, and then either have inputs or outputs attached to them via the module that you plug into this connector. So effectively what's happening is the input module plugs into the backplane, and the backplane in turn connects to the bus. And the same with the output modules. How does it work? Well, the controller is called a polar, so it polls. It's not relying on the events, it's a polling system. It will say what's happening on module 1, what's happening in module 2, and so on. And it's looking for changes. And if it gets a change in the input, it will then in turn change the output. So in effect, it's in command. What would it take to do a basic 8 input-output setup? Because remember, this only has digital outputs. Well, you'd need 3 backplanes. You need 3 modules because one has to be the controller, as you saw in that block diagram, 1 input and 1 output. So you wire the 3 backplanes together and you plug in your 3 modules, but you have to set the addresses because the input initially would be input 1, output 1. Add your second set, that would be input 2, output 2. So you require 3, 6, 7 different pieces of equipment to set up a basic 8 I/O. They sell a starter kit, which gives you the 3 I just mentioned. You're going to have your controller and your input and your output module and the address setter. So you can see down there, there's the back planes, and there's the modules being plugged into them. And there's all your connections for getting the inputs or outputs as appropriate. You can buy them on their own. You can add an extra back plane when you start to increase your setup. And you can buy a high voltage backplane. The standard backplane there has got 8 digital outputs. They go high or low as 5 volts high or 0 volts. But if you're looking to connect it to higher voltage equipment, then they have a high voltage backplane. Remember we had a discussion before about optocouplers. They're here. The outputs that come from the system, they're through optocouplers to isolate the 5 volt section here from the high voltage section here. So if you want to operate equipment at 12 volts or 15 or 18 volts, whatever, you're perfectly safe if you use the high voltage backplane. So there's 2 types. You can buy the modules on their own for just under 10 quid. But bear in mind, as it says there, they have to be used in pairs. I mean, the whole point is you've got 1 input module, 1 output module. Whatever happens here affects what happens here. Therefore, you buy them in sets of 2. So you're talking about roughly 19 quid per set of 8 IOs, not counting the cost of the backplanes. So 1-to-1 system, 1 input will change 1 output. The benefit of this one is the modules you buy, you don't have to buy 3 different modules. You buy 1 kind of module, and then you can configure that module to be a controller or an input module or an output, depending on how you wire it up. And then you set the address if it's an input or an output. You can also buy serial and USB backplanes or the PCBs for it. So potentially, if you're willing to write the software for it, you could connect it to your computer. Well, there is no kit to give you USB connections or serial connections. It's a PCB only, and there's no software. But it's there if you want to take it on. There's the address setter, roughly £8. This is the only one that uses surface mount. The rest are all through hole. What are the reporting facilities like? Well, if you've got an input or an output module, then there's a LED on that flickers quite rapidly at an even rate. In other words, the same on and off time. The control module, on the other hand, is on constantly. But if anything goes wrong on the bus, then you'll see the LEDs on the input or the output modules won't flicker evenly. They'll be uneven, and you'll know you've got a problem. So you can tell this by looking at the modules whether something is wrong. Although the modules, generally speaking, will be under your layout, so you'd have to look. Because the modules are pluggable, then you're able to unplug one module to see whether the problem goes away. If you've got a faulty module that's causing it rather than faulty cabling, for example, then unplugging the faulty module will let the rest of the system work quite happily. So, what are the good points? Well, it's mostly through hole. As you saw, the address setter is surface mount. You only need one module type, which you can then configure the way you want it. You'd only set up one controller, of course, but you can set up multiple input or output modules. That's handy, because once you've learned how to build one module, the rest follows suit. Easy to set up, because you just, assuming you've built the modules correctly, you wire them together and it should work from the get-go. It's easy to understand. You press switch 2, output 2 on the output module changes. You press button on pin 5, output pin 5 changes state. So the method of operation is very easy to comprehend. No computer required, it just works. On the downside, it's logic only. So that's fine if you want to operate LEDs, but if you want to operate, say, for example, servos, you'd have to connect the outputs to an easy points or a servo 4 board or whatever, or to a solenoid module, or to a stall motor module, like a tortoise, something like that. It's not just the modules for the peer-to-peer light that you use. You have to add on extra modules to get some activities. There's a limit of 63 pairs. In other words, 63 inputs to 63 outputs, which sounds like a lot. But of course, if you're trying to handle points and lights, and animations and so on, and signals, then 63 could be a limiting factor depending on the size of your layout. And as I said earlier, although there's PCBs for interfacing, there are no kits for it, and there's no software for it if you wanted to go down that route. Peer-to-peer light. Moving on then to EasyBus, you'll see a similar pattern. We've got a bus here, we've got input modules, and we've got output modules. In this case, the input module isn't 6 inputs, it's 16 inputs, although the outputs modules are 8. The big difference here is you can configure them to be digital I/O, similar to peer-to-peer light, or you can configure them to operate servos, or both. You can make it that the output pin changes when you move the servo, and that allows you to connect that to, say, a relay for frog switching or lighting or whatever. It's also a 1-to-1 system. Pin 5 will change output 5 and so on. Needs a controller. But in this case, the controller has got a screen and buttons, which lets you see what's happening and also makes it easier to set up when you're operating servos in particular. So a basic I/O setup here, or I should have said a basic I/O stroke servo setup, is 3 modules. There are no backplanes. You need 1 controller, 1 input, 1 output. In this case, they're all different types. There are 3 different kits. It's not 1 kit you can configure different ways, 3 different kits. The input module, about £6, the output module, about £7.50. The input module can handle 16 inputs for your £6. The output module is only handling 8 outputs for your £7.50. There's your 16 inputs coming in there. Power coming in and the connections to your bus. We don't require an address setting module. There are jumpers on here that we can use to set the actual address of each module. So it's simpler. The controller, £15, has got a screen and a set of buttons which lets you configure your system. So it's all done from the screen and buttons. How? Well, first of all, you can decide which module you want to change. This example says, look at module 1, and your up and down buttons can make it module 2, 3, 4, whatever. And when you've picked the module you want, you choose which pin you want to configure. And again, the up and down button will make it pin 1, pin 2, pin 3, whatever. So you've picked the module you want to configure, you've picked the pin you want to configure, and then what type. You can make it simply an I/O, in other words, digital, for going to LEDs or whatever, or maybe relay drivers, that kind of thing. Or you can make it a point, in which case we're looking at servos here. Or you make it a semaphore, so you get signal, arm, bounce. So which module, which pin, how should it work? If you've picked a point or a signal, you're then asked to set the values, the 2 end points of your servo. And again, the up and down buttons will pick the range. And lastly, how fast do you want to make it work? Will it snap across or will it move across gently? And you can press the test button to see if that's what you want. And when you're finished, the screen will let you know what you've done. It'll report back. You've just set pin 2 on module 1, a speed of 20, with the left and right endpoints being that. If you're happy with that, hit the right button and you've saved it away and you're done. That sounds like a lot, but it's very quick. And I've got a little video that shows it working. and just see how quick it is.
Select, proceed. Module 1, happy with that. We want pin number 6, happy with that. We want it to be a point. Set the left value.
You'll see the servo moving there.
And we're happy. Select. Press the right value. Select. Decide your speed. Test. If you're happy, adopt it. There's your values. And then you can save it.
Now, that took about 1 minute to set up that output. So it's very quick to configure any pin, even quicker if you're making a digital output, of course. So that's configuration. What about reporting? Well, the control module has got a LED that flashes all the time when there's activity on the bus, that is. There's also a button you can press to let you know what's actually on your system. So in this case, it says I've got 2 different input modules that are configured as module 1 and module 7. I've also got 3 output modules that are configured as 1 and 2 and D. So if I've mistakenly forgotten to set the address of 1, and I've got 2 with the same address, it won't appear. It'll appear once only. If I think I've set 1 to 7 and I've actually set to 5 by mistake, it'll say 5 here and I'll know if there's something wrong. So it can let you know. And if it doesn't show anything, you've got a problem in the bus in the first place. So if the bus is working, it'll tell you which modules are on there and what number they are. So that does the reporting of the setup. That reports on the status of the bus. And then even while it's running, it reports back to you. I don't know if you spotted and I was throwing the switch in that video, but every time you do it, it tells you what you've just done. In this example here, I've got a pin 8 on module 1 that's set to be just ordinary I/O. And when I throw it, that'll say high or low as I toggle it. The other example is for a servo. So it's a servo on module 1, pin 2, and it's just gone to that value. It's rotated to that value, and it's thrown its associated digital pin high. If I threw the switch the other way, it would say module 1, pin 2, the value is 92, for example, low. So it's got more reporting than peer-to-peer light, in fact, more reporting than C-bus. So what are the pros for this? Through hole, no surface mount to worry about, only 3 modules, 3 different types. Fairly simple to set up. You just use jumpers and then push buttons, as you saw there. Once it's set up, it's easy to use because it's 1-to-1 like peer-to-peer light. Input 5 affects output 5, and so on. Once again, can be set up and can be used without a computer. Another benefit it does, a servo and the logic. There are two different output pins for every output. One that can be taken straight to a servo and one that can be used to either indicate to LEDs or to relays for frog switching. And it supports semaphore bounce. And you get good user feedback. On the other hand, it only supports servos. So if you've got solenoid motors or you've got tortoise motors, then you require, once again, an additional module that you'll connect to the logic I/O pins. But if you're working with servos, then no need for the additional modules. Like the peer-to-peer light, has got no computer interface. So if you're looking to control your layout with Wi-Fi, or you're looking for a glass screen, or you're looking for automation, then EasyBus will not control it. It's designed essentially for control panels. And it's got a maximum of 128 pairs. It's double the amount of connections compared to peer-to-peer light. And you have to decide whether that's enough for your layout. Moving on, C-Bus, which is the flagship of MERG in terms of accessory buses. They sell a beginner's pack, which has got an input module. It's got an output module, comes with its own power supply, and a little diagnostics board for £53. And that'll do 8 inputs and outputs. It's like that. So you've got 8 inputs here, you've got 8 outputs there, and they connect via the bus. You can configure it using jumpers or via software that I'll talk about in a minute. These have been around for a long time. Although they are there as the beginner's pack, they're actually the version 1 or series 1 of the C-Bus modules. If you want to do it using dip switches, then I wrote a 3-part series way back in 2009 on how to set up C-Bus modules and what they call, you'll see it there, SLIM, which is the simple implementation. In other words, doesn't need a computer for this implementation. So if you buy the starter pack, then there's a 3-part series in the journal on how to set it up, apart from the documentation that comes with it. Having said that, C-Bus has also got a more modern set of modules. One that will handle servos, 8 servos, one that will handle stall motors like tortoises, and one that will handle solenoids. So depending on your type of layout, whether it's servos or tortoise or solenoids, there's a kit to handle that. And there's one, they're called the second generation kits. And you have 8 digital outputs if you want. So you've got servos, tortoises, solenoids, digital. Now, I said that you can set it up using dip switches, which is fine for a small 8 input, 8 output system. But the larger the system becomes, the more unwieldy it is to do it with dip switches. And most people at that point switch to using software to set it up. And if you want to do it via software, then you have to have a connection to the computer. So MERG supply CAN USB, which is a USB interface. And it connects also to the bus and also to your USB of the computer. And then you have to have the software to set up the various outputs. There's a lot to look at for configuring. This is what I mentioned earlier about the good points and the bad points. It's up to you. There are 28 different modules that are available for the CBus system. On top of that, there are 8 PCBs at this stage for doing extra tasks if you want. And then a couple of members have set up their own website selling another 8 different kind of modules. So we're talking about, what we're talking about, 28, 36, there's 44 potential modules you can add to your system. So that can be a pro or a con. Pro gives you great amount of flexibility. Con, how the hell's all this connect and what they're for? So there's the current software. You'll see it's called FLIM. So instead of the simple implementation, it's a full implementation. So as you can see, it can become a bit hairy or scary if you're not used to it. People who love it swear by it and say it's easy. Others who look at it are then put off by it. So it depends on how far you want to invest your time to understand how to use the software. There's some debate within MERG at this minute about the software because the main one that's used is called the FCU. But as you can see, there are other versions that other people have developed. And there's talk about whether the FCU should be updated or replaced and so on. So there's quite a bit of debate about how to control the modules. The benefit of having the USB connection, of course, is that you can use things like JMRI. And there's us able here to control a local by picking which local we want, and by also having ability to activate functions. We can control the speed and direction from here. If you want a glass panel interface, in other words, you're using your mouse to control your local, or you can use the JMRI panel editor and layout panel editor to control them, and also, if you're willing to learn more, to automate them. The reporting, a bit more limited. There's a module called the activity for the CAN, and it flashes a blue light whenever there's a CAN bus message. So you see activity, and if you press a button and nothing happens, you don't get a blue flash, then there's a problem somewhere on a module or on the bus itself. And that's about the limit of reporting at this stage in CBus, unless you're using JMRI. So what are the pros of CBus? Again, through hole, no surface mount, multiple options, multiple options, as you saw. You can have a computer interface, and therefore allows you glass panel or automation, lots of possibilities. The cons are the same as the pros, multiple choices. There's a learning curve to even know which ones you want to adopt. It's best to have a computer interface if you want to have any real size of a layout, so it's an extra cost and an extra learning curve. And it can become pretty complex if you've got a large layout and you want to control it or even to set it up, and particularly if you want to automate it. And lastly, I said I would look at the various costs involved. So if you've got a very small layout with just eight servos, now I've just used servos as a yardstick, but of course you might be using solenoids or tortoises or whatever, but I had to have something to compare like with like. So I've taken it, you've got a servo-based layout, and if you've got 8 servos only, a very small layout, then to use DC-CD coders, typically 40 odd quid. The megapoint system for that would be 66. The peer-to-peer light setup for that would be 69. The easy bus setup would be 22, and the C bus would be 53. If you then have more servos, then the costs obviously increase as you go up. If you're 32, for example, then we're looking at 84, 190, 175, 47, 122. The DC-C decoders remains a cheaper option than peer-to-peer light and C-bus, but peer-to-peer light still beats megapoints, as does C-bus. So some of the commercial systems are cheaper than some MERG in some regards, and other times, like EasyBus, still beats them all in terms of price. And if we go up to, I didn't go any further than 64 servos. And you can see then that DC-C decoders are broadly similar in price to the C-bus system. Peer-to-peer light becomes an expensive option, very similar to megapoints. And EasyBus, again, remains a very cheap option. So essentially, what we have to consider is what's right for you. I'm not arguing that any of those is the best. It's horses for courses. If you want a very simple press a button, bring on a light, then peer-to-peer light works for you. If you want to have control of servos as well as digital I/O, and you like to have more reporting and an easy setup and computer-free, EasyBus is probably an option for you. If you're happy to have a larger system and you're willing to invest time to learn how to use the software to set it up, to configure it and to run it, and particularly if you want to automate it, then clearly C-bus is the option for you. So with that, I'll open to questions and comments and discussions. Thanks.